And welcome back. We're going to continue our look at negative exponents and their meaning and how to simplify numbers with negative exponents. So for exercises 5 through 10, we're asked to write an equivalent expression in exponential notation to the one given and simplify as much as possible. Okay, so again, using our property here, right here, that a number raised to a negative exponent is the same as 1 over x to the positive version of that exponent. Or the opposite of that exponent, I should say. So here we have 5 to the negative 3, which would then be the same as 1 over 5 to the 3. Okay, for exercise 7, 3 is raised to the first power, right? I don't think this is supposed to be in parentheses. I think this is supposed to be 3 to the first and 2 to the negative fourth. So it's going to be 3 times, let's go ahead and rewrite that 2 to the negative fourth as 1 over 2 to the positive 4, which yields 3 over 2 to the fourth. It's up to you if you want to actually expand out that 2 to the fourth, and make that like a 3 over 16. I think either of these are acceptable. Okay, although it does say simplify as much as possible, but this is going to be a really big number. So anyway, let's try number 9 though. Oh, these are going in different orders here. Oh well, whatever. This is fine. They changed the exercise order up on me in this one. Let's rewrite this one. Okay, so we have 1 over x to the 9th. So in this case, we'll go ahead and use negative exponents. Okay, so this would be x to the negative 9, like so. Why don't you guys go ahead, pause the video, try 6, 8, and 10 over here. Okay, so you can kind of use these as examples to help you in your efforts. All right, hopefully you pause the video. 1 over 8 to the 9th will be 8 to the negative 9. X to the negative 3, we can rewrite that as 1 over x to the positive 3. And then again, xy to the negative fourth, again, I really feel like it's only the y that's being raised to the negative fourth. I don't think there's supposed to be parentheses here. So it's going to be x times 1 over y to the positive 4, which results in, if you put x over 1 like that in a fraction, x over y to the fourth, like so. Okay? So, with negative exponents, the same rules still apply. So for example, the older rules still apply. So if we have, for example, x to the a times x to the b, we can still get away by simplifying this by simply adding those exponents together. Same base, add the exponents. Okay? In this case, I think we are supposed to have parentheses here and parentheses here. When you have a power raised to a power, even if it's negative, you multiply those two powers together to simplify. And then here where we have two bases, right, the power will distribute to both bases. So it's x to the a, y to the a, like so, even with negative numbers. Okay? And again, there should be parentheses here. So let's do some more examples here. So 19 to the 2 over 19 to the 5 is going to become 19, well, it's 2 minus 5, which would be 19 to the negative 3, which typically we would rewrite then as 1 over 19 to the third. Typically, you don't end with having negative exponents in your answers when it's simplifying. Okay? Why don't you go ahead and try 17. Pause the video, give it a go. Or 17, try exercise 12. 17 to the 16th over 17 to the negative 3. Okay, hopefully you pause the video there. You should get 17 to the 16 minus negative 3, which instead of subtracting a negative, we can add a positive here and make it 17 to the 19th power there. Okay. So, if we let b equal negative 1 and 11, a be any integer, and y be any positive number, what do you get? I am not sure what they're referring to here because this is 11 and there's no a's and b's in it. It might be referring to stuff up here, but it's unclear, so we'll just skip this one. Show directly that this is true. Okay, so again, I think there should be parentheses here. So let's just use our properties, right? We have a fraction, and we're going to, again, distribute that power. So, whoops, we'll get 7 to the negative 4 over 5 to the negative 4, which is exactly what we see right there. So check, it works. Okay. And that is the last bit of those properties there. We're now at the problem set. So yeah, we'll end there and we'll see you in the next lesson.